Hey guys, welcome back to another video. In today's video, we're going to be talking about AP Physics 1, Unit 1, Kinematics. And in this video, I'm going to be doing some review questions, and hopefully by showing y'all how to do them, y'all can learn how to do them for other kinds of problems that are similar. Okay, so let's begin. So imagine you have a ball that is launched 30 degrees above from the horizontal at 50 meters per second. We're going to be looking for how long does it take for the ball to hit the ground, or like how long does the ball stay in the air. So let's say this height is equal to 0 meters and this height is also equal to 0 meters. So we're looking for time. How long does it take for the ball to hit the ground? And to get the answer, we need to use some kinematics equations. But before we use the kinematics equations, we have to split the velocity vector into its x and y components. As you can see, only the y component will really matter for how long it stays in the air, because x would, if there was no gravity, it would just keep on moving in a straight line, right? But since there's gravity, the y component will be affected, because imagine there's like no horizontal movement. It just goes up and then it goes back down. It doesn't matter like how fast you're going horizontally. All that it depends on is the y initial velocity. So let's split the vector into its components. So to find the components of a vector, you use trigonometry. So essentially, this is the hypotenuse, and this is the opposite, and this is the adjacent. So what trig function gives you the opposite? Sine. So if you multiply the hypotenuse by the sine function, you will get the opposite. Because remember, sine theta is equal to opposite over hypotenuse. So if you multiply, the hypotenuse by the opposite over the hypotenuse, you're going to be left with the opposite. So since we're only looking for the y component, because x is not really relevant here, it's just 50 times 1/2, which is equal to 25 meters per second. So we have to find out that this component is 25 meters per second, and that's all we really need to solve the problem. So we're given x initial is equal to 0, and that x final is equal to 0. And that velocity initial is equal to 25 meters per second. So we are looking for the time. We know the acceleration because we are on Earth. We know the acceleration is just negative 9.8 meters per second squared. So based on that, we need to find an equation that satisfies all 5 of these variables. Let's start with the first one. This one has velocity final, which doesn't show up here, so we can cross this one out. This one has all 5, but let's see the last one. This one has velocity final, so we don't use this one. So let's use the second one. So by rearranging some variables, we know that these two are 0. So we're left with 0 is equal to Vy initial times time plus 1/2 acceleration due to gravity times squared. Yeah. So we can factor out a t from this remaining equation. So we're left with 0 is equal to velocity initial plus 1/2 acceleration in the y direction times time. Since we're left with this, let's make some room here. So rearranging this, we're left with 1/2 acceleration in the y direction times time is equal to negative velocity initial. Yeah, that's kind of it. So let's put t on its own. So as we can see, we have a fraction here. So I multiply both sides by 2. We get rid of this. But as you can see, there's a y, I mean not y, acceleration in the y direction here. So if we divide by acceleration in the y direction on both sides, we're left with t is equal to 2 negative velocity initial in the y direction divided by acceleration in the y direction. So let me make some more room here. So now we're left with this equation, and by plugging in some values, we get that negative 2 times velocity initial, which is 25, divided by negative 9.8 meters per second squared. And these negative signs cancel out, so we're left with positive, equal to 50 divided by 9.8, which is approximately 5 seconds. That's our final answer. On the AP Physics test, you can say that acceleration due to gravity is negative 10 meters per second squared, and it'll still be right. Okay, so for this next problem, an object is thrown horizontally at 30 meters per second at a height of 10 meters. So we're going to look for how far does this object travel before hitting the ground. In terms of x, how far does it travel before the ball hits the ground? So first, what we need to do is find how long does it stay in the air. We're going to use the kinematics equations again, and the one that we're going to use here is the second one. So essentially, we have that our initial height is equal to 10 meters, and that our final height is equal to 0 meters. Let's put y here, because it'll be confusing if we have two different forms of x. So using this equation, we have our initial and final heights, right? But what is our initial velocity? Well, since there's no velocity in the y direction, but only in the horizontal direction, you can say that velocity initial is 0. And for this term, acceleration due to gravity, let's use negative 10 this time. So let's start finding out the equation. So we have y initial is 10 meters, y final is 0 meters, velocity initial is 0 meters per second, and acceleration is equal to negative 9.8 meters per second squared. And we're going to be looking for time. So let's start with this part. So we have x is equal to whatever the rest, right? So we can rewrite this. If we subtract x initial, we get change in x. Change in x is 0 minus 10, which would be equal to negative 10, and is equal to the rest of the equation. So we're given that velocity is equal to 0. So we have 0t, which is just 0, plus 1/2 at squared. So multiplying both sides by 2, we're left with at squared is equal to negative 20. Remembering that a is equal to negative 10, we divide both sides by negative 10. Right, we're left with we're left with t is equal to 2, right? And that t is equal to square root of 2. Okay, so we're left with time, but to find the x traveled, we're going to use the velocity times time. Because remember, velocity is equal to change in x over change in time. But if you were to put this over here, you get this equation. So let's see, we have initial velocity of 30 times square root of 2, and that will be approximately 42 meters. So in summary, this object released at a height of 10 meters, traveling 30 meters per second horizontally, will travel a horizontal distance of 42 meters before it hits the ground. Hooray. If you made it this far, thank you for watching.